Hello, crazy cats and dogs and people and parrots and things. Yeah. Anyway, here we're going to solve some trig equations. We're going to algebraically solve for the exact values of all angles in the interval 0 to 2 pi that satisfy the equation. Please remember that when we're doing our unit circle here, that the first coordinate stands for cosine and the second coordinate stands for sine. So this problem is basically asking you to find when sine is a half. Well, when is sine a half? Let's go ahead and look at the second coordinates. It looks like I found a 1/2 here. I found a 1/2 here. This one doesn't work because it's negative, so that's no good. This one doesn't work because it's negative, that's no good. So our answer on this particular problem is that x is going to be equal to 5 pi over 6 or pi over 6. Are those angles, those radians, are they in between 0 and 2 pi? Yes, they are. So those are our solutions. Okay, let's check out this one. Here we've got sine of x equals negative root 3 over 2. And in this particular problem, I'm looking for the second coordinate being a negative root 3 over 2. So where do I find that? I find a negative root 3 over 2 right here, and I find a negative root 3 over 2 right here. So it looks like to me that those two answers are 4 pi over 3 and 5 pi over 3. So we've got an answer of x equals 4 pi over 3 and 5 pi over 3. Are those in the interval? Of course they are. So now let's beef this up a little bit. Let's solve the following. And you might recall that we have to factor this first, and then we can set our two parentheses equal to 0 and solve. But first things first, we have to set x equal to sine x. And let's rewrite this as 2x squared minus x minus 1 equals 0. So here, we're trying to multiply to 2 times negative 1, which is negative 2. And we're trying to add to the middle term. In this case, that's going to be a negative 1. So we're trying to add to negative 1. Think of two numbers that works for. I believe it's negative 2 and 1. They both multiply to negative 2, but they add to negative 1. So we're good to go there. I'm now going to split this up right here into two different things. I'm going to keep that 2x squared. And of course, I'm going to put the negative 2 first because that matches with the 2x squared. Then I'm going to have a 1x, then a minus 1. Underline, underline. I'm going to pull out a 2x. That leaves me with an x minus 1. I'm going to immediately write x minus 1 right here. And I'm left with a plus 1 on the outside. So that's going to give me a 2x plus 1 and an x minus 1. And again, you can rewrite that the other direction. Doesn't matter to me one bit. All right, so now let's rewrite this as 2 times a sine x plus 1 times a sine x minus 1. And this is the same thing we've been doing, but now we've got to take that extra step. And what we have to do next is set those both terms in the parentheses equal to 0. So let's start with the first one here. The first one being this one right here. We're going to have 2 sine x plus 1 equal to 0. I'm going to subtract 1 from both sides. And I get 2 sine x equals negative 1. Next thing I'm going to do is divide by 2. The 2's cancel, and I'm left with sine x equals negative 1/2. All right, let's deal with that at the end. Let's now solve this one for 0. So here I've got sine x minus 1 equals 0. Add 1, and I get, I don't know, I put equal there. Add 1 to both sides, and I get sine x equals 1. All right, now let's go ahead and check our unit circle. And for our unit circle, I'm going to find places where I get a negative 1/2 in the sine, which would be the second coordinate. So let's see where I can find that. I find that right here, and I find that right here. Now let's focus on this one. I need to find when sine of x is 1. Again, that's that second coordinate. When is it 1? And I see that right here. So what are our answers? Well, we have to find the radians associated with those values that I circled. And we've got x equals pi over 2. That came from this one. And then I've got a 7 pi over 6. And that one came from this one. And lastly, of course, we've got our 11 pi over 6. And all of those are in the interval that we want. There we go. All right, moving forward. Let's try example 4 here. So example 4, we have to factor. So this is going to be 2x squared plus x minus 1. We are trying to multiply to negative 2 and trying to add to 1. Those values are 2 and negative 1. So I'm going to split this middle term up, and I'm going to have 2x squared plus 2x minus x minus 1. Okay, next thing I'm going to do is underline, underline. Pull out a 2x. That gives me x plus 1. So I immediately write x plus 1 here. And I know a negative 1 goes out in front. So this simplifies to be 2x minus 1 and an x plus 1. And I'm going to substitute back in that cosine x, so I get 2 cosine x minus 1, and I get a cosine x plus 1. All right, now we're going to have to take some time to set those equations equal to 0, then look at our unit circle and find our solution. Let's go ahead and let's start with this one first. So we've got 2 cosine x minus 1 equals 0. Add 1 to both sides. The 1's cancel, and I'm left with 2 cosine x equals 1. Divide by 2. 2's cancel, and I'm left with cosine x equals 1/2. Again, we'll come back to that in a hot second. Let's deal with this one now, cosine x plus 1. So here I get cosine x plus 1 equals 0. Subtract 1, and I get cosine x equals negative 1. All right, now we need to identify the places in our unit circle where we get cosine of x is 1/2. Now cosine is the first coordinate, so I need to look for 1/2 in the first coordinate. I see 1/2 here, and I see 1/2 here. Now I've got to deal with this one. I've got to find when the first coordinate is negative 1. And I see that happens right here. So now let's go ahead and write our answers, and that's going to be the radians associated with those particular ones. So we've got x equals pi over 3 for this one, a pi for that one, and a 5 pi over 3 for that. Now I want you to assume that I'm asking you for all the values in the range of 0 to 2 pi, because if I didn't, there would actually be an infinite number of solutions. You could actually add 2 pi to every single one of these problems. But don't overthink it. I just want you to answer in the 0 to 2 pi range. All right, that's it for this video, folks. Hope you really enjoyed it. I enjoyed teaching you. Take care.